Um. Anyway, so the big thing about the hangman problem is that is the idea of word categories. The idea here is that we are not committing to a single word. Instead, we are basically using the entirety of the dictionary to help us here. And we are just going to say, hey, if I can, if they choose a letter, I'm going to choose I'm going to basically figure out all the different results that could happen from that. So, for instance, let's see. Give me 1 second to pull up my assignment for you, just to show you. Okay. Maze, pound, punt. No, quick sort. No. Hangman. All right. So here, right? The idea here is that say these are the only 4-letter words in the English language, and we're playing hangman with them. Rather than choosing one of these words, the player chooses the person who's playing with the hidden word, the person who's not the
This
guesser.
team looked good.
Mm-hmm. Yeah. The idea here is we're going to we basically just say we pretend we picked one of them, but in reality we're just knowing all of these. So player starts by guessing E, and so what we do is that we look for all the E's in our letters and we categorize them into word families, which is basically if we were to commit, basically since they've guessed E, we have to say basically we don't see an E, or we have to reveal one or more E's, right? And we have to commit to one of those choices, which will narrow down which cuts down the number of words we can go with, right? For instance, if we say, oh, there are no E's, we can't use any of the words with E's in them anymore because they run out of guesses, and we say, I was thinking of edge. They'll go, but, wait a second. E was my first guess. You cheated. So, if you guess an E, then here's the possibilities of what I might reveal. I might reveal nothing, in which case the only words I can use now are this, look, and good. If I reveal an E at the beginning, then I can only use eggs or echo. If I reveal an E in the second position, that means I can only use team, right? Because again, remember, this is all I have. And then if I reveal E blank blank E, then I'm committed to the hidden word being edge. So we split it up into these families, and then we choose one of these families to go with. What family do we go with? I'm gonna pretty much go with the one I suggest, the strategy that's easiest, which is choose the one that has the most choices in it. So let's go with blank 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 because that gives us the most words to work with in the future. So now that means we reveal blank blank blank, and we narrowed our list of words down to this looking good. If they guess O, we now split up our remaining words into further word families, which say, hey, blank O blank, which would be looking good, and nothing, which contains this. And so we'll say, okay, you got it right this time, and reveal 2 O's. The idea here is that we narrow down our choices, or we try to narrow down our choices as small as possible. And that will get increasingly frustrating for the player. Now, the way we do this is to use hash maps and to use a couple of different functions. I highly recommend using a bunch of different functions. Hash maps, as you'll learn, are used for 3 different things. Okay, 3 big primary things. The first is key value storage. So like doing something with a database. Make sense?
Yep.
So like here's the student ID. Give me all the information about this person. Okay. Next thing is counting. So given the key, so basically this says here's the key, and the key might be letters or words, and the value is this is how many times I've seen it. It's very useful for when you want to count the number of times things appear, but you don't know in advance what the things are going to be. And the last common use for it, which we're going to make use of here, so we're going to use counting and this last use, which is categorization. And categorization is basically saying if I've got a key, which is which can be anything, here's the list of all the things that end up in this key. Now, again, maps, because maybe you probably haven't watched the videos yet, the entire idea of a map is that it's an arbitrary, it's basically creating an arbitrary association between two things, an arbitrary mapping. They're sometimes called associative arrays. Basically, they're arrays where you can just make up the indices. That's how they're treated in some languages like Python. Although in Python they're called dictionaries. So associative arrays, hash maps, hash tables, dictionaries, they're all referring to the same thing. But they are the most powerful data structure out there. They can run in constant time for most of their operations if you don't care about what order stuff is going to be inside the array. So you're going to want to write so refer back to this video or this code in a bit. When you're doing this, you're going to want a couple things. You're going to want public static. So first off, you're going to want, basically most of this will be done in main. Okay. You'll want a function to basically to take in the word file and split it up into its constituent parts. So like for here, what you'll want to do is maybe write a method for that. Public map string. And notice that we're going to have two arguments for the generic. Basically, the type for the key and then the type for the value. Actually, it's going to be integer, list of string for this one. Public static map. So this function, what this function will do is that this is like the first, you'll run this once whenever you run the program, which will basically read your dictionary file and basically separate out all the words into different, basically it will categorize all the words based on their length. So for instance, the key might be 4 and the value is going to be basically all the 4-letter words like word and help and toot and boot and iron and fist and
edge,
basically all the 4-letter words it will find,
which includes all of the 4-letter words
that are fun. All right, so anyway, and then 5 would have all the 5-letter words, okay? And as you'll see, the way that you do handle this is that basically the way basically these operations will work is as follows. First, you'll want to create you'll see, but basically you'll want to create a list, and you're going to store it in the map, and then you're going to retrieve that list and add things to it. The next thing, the big one that you're going to want to do is public static map is another categorization. This time string list string. And the reason I'm doing this is to show you what all you need to calculate it, which is create word families. Okay. Create word families, which takes in a list of string words and set. And set being is the other thing that you've learned, is the other thing you're going to learn about in this upcoming chapter. And sets are super easy. They're literally mathematical sets. But why do I use them here instead of a list? I use them here because these things are constant time lookup, just like your maps are, and they're fantastic for telling you whether or not something is already in this set. It can do so in constant time, which means basically the person guesses E. Great, that works. But then they try to guess E again. You can immediately tell them in constant time, wait, you've already guessed E. No, you don't do that again. So.
Or you could just let them and have it waste a guess.
Yes, but according to my requirements of the assignment, you should tell them. All right, so for this one, basically what you'll do is that this one creates the word family. So it takes in the list of all the words that you are currently thinking that you can currently give as an answer based on the current number of guesses. But the user has just added a guess. So you need to split this list of words up based off of what you'll reveal. So in this case, the key is basically what the series of blanks is going to be. And the value is all the words that belong to that word family. And then you'll probably want a public static string best family, which will take in what you created in the previous method, which is string list string families. So it's going to figure out what the best family is. Right?
Mm-hmm.
So those are your three. I know that won't make too much sense at the moment, but you'll want to, when you do this assignment, you'll want to have those three methods in mind for how you break up the work. I highly recommend doing, if you can do this one, you'll be well on your way to doing this one, which requires a bit more work because you got to figure out how to create a family, but that's okay.